And the nice thing about this arrangement is that I can immediately cut a second strip of the same thickness without making any adjustments. Also, there's no limit on the upper length of the piece of wood. This is the surface that was cut by the blade. It's very smooth. The riving knife is a wedge. It starts at a thickness slightly less than the kerf of the blade and then grows to a thickness of 3/8 of an inch. And all that growth is on this side. This side stays parallel with the blade. I stopped part way through this cut because I want to show something. The wedged riving knife is pushing this outward, and that's operating almost as a feather board pushing this wood in. So if I pull that away, it snaps back. There's a straight line surface all the way down here. This is parallel to this, that's keeping this piece of wood in place. So as I get near the end of the cut, it's held in place right up until it runs out of fence. The piece is coming out flat. It's the same thickness on both edges. I marked that right on the fence plate. And that's not the thickness of the plate, it's the thickness of the strip that will be cut when that plate is installed. The thickness of the fence plate determines how thick the strip will be that gets cut. So I made plates of a few different thicknesses. The face plate slides, and you want to bring it up close to the front leading edge of the blade. And of course that'll be different depending on the height of the blade. I found it helpful to cut the end of the push stick on an angle so that it holds the piece of wood down at the end of the cut. The variation in thickness, when I measure it at different points along, is less than 5/1000ths of an inch. You can attach a blade guard to the fence, and that could be clear plastic. The bottom has one tight-fitting runner and a cleat at each end so that it sets into the table saw and does not move. Here's how I aligned the fence with the blade so that it gets glued in place parallel to the blade. This kerf slot was cut before the cleat up here was put on by sliding the board forward into the spinning blade, and then the riving knife glues into that slot of the kerf. If I was doing this again, instead of gluing this cleat on, I would screw it on, and then I could remove it so that if I ever have to replace the riving knife, I could just slide the sled forward into the blade and let it cut through the riving knife and make a new kerf. Another thing I would do different is instead of having the grain running this way, I'd have it running vertical or maybe on an angle, because when it runs this way, it's not very strong. It could break off because it's only an 1/8 inch thin at the bottom, and also it's more inclined to warp. So grain on some kind of an angle would be better. When you're done, don't forget to put the riving knife back in. And here's a handy way to glue those hardwood edges on so that you don't need a lot of edge clamps. Hardwood edging glued onto the edge of plywood to make a nice finish. And now, of course, I've got to trim off the excess. And a way I've found very good to do that is with an L fence, so that the blade can be just even with this face of the fence and then run along like that. A challenge though is, when you're doing a lot of it, is how to keep this good and snug against the fence, because the plywood may have a slight warp in it. Just keep it in there good, and you don't want it drifting away. So a feather board is the standard solution, and two problems. One is it's going to hit the trim, so you kind of want it up there. The other is I don't really want it at the bottom here. I'd rather have it hitting more in the middle of the fence, because that's going to keep it against. Because if it's all at the bottom, the fence can still tip out this way. So what I thought is I've got to somehow elevate that feather board. And the solution is a little bit of a wooden T-bar that fits in this track, and then I just glued another piece on top. I'm just using scraps. And that slides in the miter slot and will not lift out because of the T. So all I need is something to secure this and something to secure here. And I'll use threaded inserts to secure it all together. These are made by Rampa. Other people make them as well, and they're very handy for jigs and that sort of thing. So I've drilled a 7/16 diameter hole. These are 1/4 20. They fit good in that. And then a 5/16 clearance hole for the bolt to go in. And a little trick is one of these tools, which screws onto the threaded insert, and then you can get it started easily. And I made this block so that I can keep it perpendicular. I just go a couple of turns to get it started, and then finish up with a 6mm hex wrench. And you don't need any countersink here. It's a very shallow part on the top. It'll just dig into the wood there. So one of those at each end, and then one in the middle. This one will hold the featherboard. So this slides the position I want, then locks in place with these bolts that are going through the threaded inserts, and then it will not move. Then I can set the featherboard nicely. So that does a pretty good job. There's the edge there. I've left, I don't know, 5/1000ths of an inch, so there's a bit of glue, and I can just run a sander over that or a hand plane. Gives a good looking finished edge, and it's very durable because it's hardwood, much more durable than the iron-on veneer.